Good day, everyone, and Assalamu alaikum. On behalf of Global CIO Forum, Atos and NVIDIA, I welcome all the online attendees to this live virtual summit titled Transforming AI and the HPC Landscape. In this live virtual summit, we will understand breakthroughs and convergence of AI and high-performance computing in business applications, use cases of AI across industries and recent projects by Atos and NVIDIA, how high-performance computing is a critical part of computational sciences. Moving forward, high-performance computing is now part of weather forecasting, energy exploration, fluid dynamics, life sciences, amongst others. And simulations are fusing AI, machine learning, deep learning, big data analytics, edge computing to solve tomorrow's problems of science and the world. Leading us through today's live virtual summit are Mehdi Kasmi, Global Head of Sales, Vertical Offers, Edge and AI at Atos, Dr. Cedric Bourasset, HPC and AI Global Business Development at Atos, and Timothy Lanphier, Director, Solution Architecture and Engineering EMEA at NVIDIA. So now, before I hand over to Mehdi Kasmi, here are some short housekeeping rules. All attendees are on mute throughout the session. However, we encourage attendees to ask questions through the chat option, and the speakers shall answer them at the end of the session. So now over to you, Mehdi, to begin the session.
Thank you, Aaron. Hello to everyone. Hello to everyone, and welcome to this webinar. In today's webinar, I will do a very short introduction on who we are. Then Cedric will be presenting advancements in high-performance computing. I will be then presenting what we can do on analytics and how the data analytics, computer vision is shifting to the edge for the inference. We will be also talking about the accelerated data center, and we will end up with Atos and NVIDIA joint value proposition, followed by a Q&A. To get started with who we are a large company who is a system integrator. We are also a leader in cybersecurity, leader also in HPC. We build our own servers, and we are also a software vendor. We do roughly 12 billion of revenue worldwide. We are the worldwide IT partner for the Olympic Games. And we spend more than 230 million of R&D per annum. We are located everywhere in the world with a global coverage, and we do have also an entity called Middle East, Turkey, and Africa, with a presence in Africa, in Middle East, with 40 countries, 20 offices, and 4 Middle East and Africa delivery centers. I will now hand over to Cedric Bourasset, who will be presenting advances in high-performance computing. Cedric, floor is yours.
Yes, thanks, Mehdi. Hi, everyone. So in terms of HPC activities in Atos, to continue who we are and what we are doing. So we are one of the top 5 worldwide company in HPC. We have a 20% growth year to year, and we are the #1 in Europe, India, and Latin America today. And we have many experts and customers that are spread across the world. Our vision in terms of the advancement and the evolution of HPC for the future is for us to help our clients to achieve new breakthrough in science and business, thanks to or HPC capacity, with now some new AI capacity that augment HPC and some quantum simulation as well. So we are designing and building our own technology, which is one of the most energy efficient technology for HPC. We bring now AI capacity in the HPC world, and we are bringing also HPC capacity for the AI world as well. And one of the key advances we are seeing in the simulation world is the use of quantum computing. And our vision is we are developing today a quantum simulation appliance that can be used to provide an universal gateway to quantum hardware. And one of the key things is the decarbonization ambition of Atos to reach the net zero by 2028. So in HPC, in fact, it's one of our key vision is to be the leader in energy efficient supercomputing, being the #1 in green HPC. And in fact, we have more than a decade of innovation in being and building energy efficient technology, with today more than 70 patents just for the cooling of a HPC system. And we have the most efficient energy design with what we call a PoE, so an energy efficiency at 1.02, so meaning that almost each what you consume in the system is used for the compute. And we have more to come with smart DC and green energy. And if you look at today what we call the green 500, which is the greenest HPC system in the world, we have 40% of the chart in the top 10. So meaning that we are today the best vendor and the greenest vendor in HPC. This is one of our vision on the evolution of the HPC. Of course, we have many different ways to build energy efficient HPC system, and we design and assemble what we need to match real expectation on our customer. So it could be whatever the technology you will need in terms of air cooling, water cooled doors, or direct cooling. We are able to design and customize a solution for a specific application or a specific research domain. And of course, we are working with all the best of breed partner in hardware, on the interconnect side, on the storage side, and on the software side, to bring the best and the most efficient solution for each customer. In terms of use cases, because technology is good, but use cases is key. Today, our team are working on many different domains, and in fact, each market, each application can benefit from a solution, from our solution in HPC and AI and quantum. Could be, for example, big system in manufacturing, for example, to validate vehicle design, to do engineering of plane. Also on the healthcare side, we have many of our HPC systems that are used for genomics, drug discovery, for example, vaccine research. Like we allow some of our healthcare customers to access our HPC system for the COVID research. And public sector and defense is also one of the key sector for us, bringing solution for research to be able to accelerate science breakthrough. So whatever the industry we are working, we have a very strong presence, and our vision and what we are seeing today, and one of the main market for us is the weather and climate market, where we are present for more than a decade. We have most of the European center are working with us. The latest one we have built a collaboration is the ECMWF, which is the European Center for Weather Forecast. That is a very well-known research institute in the weather forecast domain, where we are doing with them many development, and we are helping them to enhance their application, enhance the performance of the system, to be able to better simulate, to be able to better, for example, predict the trajectory of a typhoon or tornado or things like that. So that's one of the key message and key domain we are working today in Atos to bring expertise and to advance this world in terms of having new technology to better simulate. And for example, one of the key projects we are working is the use of AI and the use of machine learning in the weather and climate modeling. We have built a center of excellence between ECMWF and Atos, and the objective is to advance the state of the art of the current way to simulate the weather forecast and the climate change by bringing AI and machine learning technology in such workflow. And the objective is to see how we mix and hybrid AI, so machine learning technology, with the standard way to compute and to solve this kind of use cases. So we have a 4 years collaboration between the ECMWF and us that is very promising, because we are seeing that AI bring a very interesting way to first better simulate by being able to extract from the data things, I mean, information we are not able to solve manually, but also in the way to replace a part of the simulation directly. So that's a very promising work. That's a joint R&D, and that's a way all our customers that are using HPC and making science simulation are progressing in the next years to make hybridization between AI technology and standard HPC workload. To support those use cases, we have built a specific technology, specific software library to boost the hybridization in HPC and AI, because in such use cases, the main needs you will have is be able to develop an AI model that is able to simulate physical phenomena. So it's a complete part of the AI research domain today to build and to develop a new deep learning and machine learning architecture to surrogate the physical equation. So we have a complete set of model we have developed with research people on this. And then one of the key things to move from research to production is how we support and build technology to enable the hybridization between standard simulation and the AI model we have. So it's a complete part of engineering of how you put this in production in a big HPC supercomputer system, and how you build the AI model at scale on such system. And the first part is more on the research side, is how you have an automatic loop of and strategy to automatically optimize hybrid workflow between HPC and AI to better simulate at the end. So that's one of the key use case we are working on, and we are building technology, and it's very important for us, to support all of customers to go from standard HPC simulation to hybrid AI HPC simulation. That was for the advance on the application side. On the hardware, as our platform are evolving in more and more AI, we are building converged infrastructure to support both HPC and AI needs at scale. One of the key recent achievements we are working on is Leonardo in Cineca, which will be the pre-scale system in Europe that will be the world's largest AI supercomputer with more than 300 petaflop system. So it's a massive and huge capacity that will be stand in Europe to support all the research in Europe with this both AI and HPC capacity. Then what is new in what we are seeing more and more is the need of using HPC to transform AI. So on this slide, you have the evolution of the compute need to train AI model. So what we are seeing is more and more we are progressing in the AI world. More and more compute power we need, and at some point we are seeing a big trend and a big needs to bring our supercomputer capacity into the AI world, to transform this AI world and to be able to have new breakthrough in AI in terms of modeling, creating a bigger model to, for example, better translate between one language to another one. So that's key today to bring this AI world to the HPC world, to enhance and to continue to boost innovation in the AI. And that's why we decided to build a specific offering in Atos called Think AI, where the value of Atos is to bring large-scale computing to AI people by bringing expertise, bringing all our knowledge in creating and in scaling AI application and AI training on HPC system, being able as well to architecture a dedicated AI training system with HPC technology by bringing best of breed of partners, of course, Nvidia technology, but also some new dedicated AI chip technology that are part of this portfolio. Bringing as well software to be able to manage workflow and operation in such system. So bringing data science platform that can scale up to the exascale, for example, bringing also expertise and a lot of value on digital security around the AI platform. So all we do, for example, a shared infrastructure and a multi-tenant infrastructure for an AI platform, and also all we work on AI risk on the application side with enterprise customer to see if your data can be a way to attack your application at the end. And of course, as a technology provider and integrator, or one of the key assets we have is a smooth integration and delivery of this big system to any customer, making sure all the building blocks are very well connected, very well designed to be able to scale, because what we know is this compute needs in AI will continue to grow and to explode. And when we design a system, by Earth and by default, we take into account the future need in terms of scalability to make sure when the compute need will grow, it will be smoothly for a customer to go at the next stage in terms of scaling. So that's a way to today we are seeing on this transforming the AI world, thanks also to the HPC capacity we have in Atos. Last but not least is the hybrid HPC Cloud. Today, we in Atos we have acquired Ninbix company, which is one of the key leader in HPC as a service. So one of the key objective today is we are building on-prem infrastructure for a customer, but also there is a lot of AI capacity and HPC capacity that could be accessible from the cloud. And today, with the Ninbix technology, we are able to manage hybrid model between an HPC AI on-prem system that is used for training, and with a direct capacity to burst and to go to the cloud environment. So Ninbix technology has been designed to manage most of the CSP capacity, have a native support for all the accelerator, and it's a way for us today to bring ISV application and in any HPC infrastructure that could be on-prem or in the cloud or a mix of both. For example, you want to keep some data locally, you can have an on-prem infrastructure, but if at some point you want to externalize some services on the cloud, automatically you will be able to burst into the cloud. I think I will give the speech again to Mehdi. Thanks for your attention.
Thank you, Cedric. So now we're going to the third section, which is about data analytics and how the compute is shifting to the edge and is being impulsed by AI. So what's happening in the market is that when we're talking about AI, there are many topics related to data. And data, when we look at all the data that are being generated either by IoT, by cameras, by people in softwares, only 5% of it is being analyzed. 80% of those data are images or video, and they are not analyzed because of their complexity. And we see now that computer vision is mature, meaning that the models in computer vision allows you to have, in average, 80% of accuracy when it comes to detecting a behavior, for instance, in a camera. So with those data, what we see is that many applications that are that can be industrialized are based on video. Then I spoke in the title about edge computing. What is edge computing? When you have data to be analyzed, you want it to be analyzed real time, meaning with no latency. You have to go to the edge. When it comes to have local decision, assume a nuclear power plant or an energy power plant, you don't want to send the data through the internet to have an answer. What happens in case there is a connection drop between the factory or the power plant to the rest of the world? So you wanted to keep it local. The other thing is that sometimes when you analyze some data, there's a so huge amount of data that network cost becomes an issue. The other thing is that sometimes your data are very, very confidential, and you want to keep them not only not in a cloud, it could be a private or even a public cloud, but you want to keep them locally to be analyzed locally. You had that case, for instance, with a large manufacturer building aircrafts who didn't want to have any data going outside of the manufacturing plant because all the images were images of defect, because they were doing a quality inspection using vision and computer vision. And then if you bring one of those criteria or more than one of those criteria, you probably should implement edge computing. And now with the 5G deployments across the globe, more and more compute will be done at the level of the base stations. So there will be compute to avoid any latency, because we will be able to send a large amount of data outside of a site, for instance, but won't have the capacity or we would not need the latency to run the compute on the cloud, and we would need it at the edge. So edge computing is clearly cross-industry technology. Okay, we can use it in preventive maintenance, in video surveillance, in manufacturing, could be on quality control, on worker safety, could be also in smart cities, in retail shops, counting the number of people, looking at what are the goods that are being touched by a customer and not bought by customers. So all this can be implemented using AI, using computer vision, using edge, but using also high performance computing. So we at Atos have developed a solution called Computer Vision Platform, where the basis comes from our acquisition of a software vendor called Ipsotech, who is one of the leaders in computer vision. We do have pre-trained AI models that we can run anywhere. We do have GPU-enabled hardware, thanks to the edge servers we develop, the high-end servers we manufacture, and also HPC. and thanks also to the NVIDIA accelerators. We built also computer vision labs across the globe. So, and there's one in Middle East based in Dubai that you can visit, where we have expertise. We have our software experts. There are some people from NVIDIA who can help, and we do have also our hardware that you can test. That software is a kind of toolbox where you can have, for instance, people counting. You can have vehicle detection. You can have any type of features you want in computer vision that we will assemble together to create a business process based on computer vision. And basically, if we look at our computer vision platform, the goal is to serve multiple use cases that I described earlier, rely on our software stack. So some examples are behavioral analytics, are facial recognition, object detection, traffic monitoring. But what's happening is that we are able also to create custom AI models using our data science and data engineers. And when a solution is not in our platform and doesn't make sense to develop it from scratch, we have a set of partners who are able to connect to that platform to add additional features to it, like violence detection in a crowd, for instance. We are developing also the hardware. So from very small boxes called Edge Nano to edge servers, which are ruggedized servers that do not need any data center environment to run, meaning that you can install them on a desktop. You can install them using a Visa mount kit, so the same mount kit as for maybe your TV at home, and you can plug it on a ceiling or in on a wall, for instance. We do have consulting services who can help you looking at your business drivers, what type of AI needs to be implemented, working with you on the business case. And when we deploy edge computing at scale, of course, you would need managed services that we can also deliver. So the applications that we are able to run are based on pre-trained models. So here are some examples on traffic management, abandoned objects in metros, detecting objects on the track, crowds in action, doing some perimeter protection, or more kind of use cases based on safety, like if people are wearing their protective equipment on an oil rig, or if there's some smoke in a specific location. And the full range of computing server is something really important, because you can, for instance, train your model on high performance compute. You can do inference in a shop where there's only 2 or 3 cameras on the Sequana Edge Nano, so a very small box. If you have a store, for instance, of with 30, 40 cameras, you could use the Sequana Edge to analyze the data, the video stream real time, and send just only the alerts to a command center. We do have the Sequana SA20G, which does the inference, but can do also a training, and that is running in data center. And if you have, let's say, thousands of cameras to be analyzed, then we move again to high performance compute. And clearly that solution is not edge nano, or edge, or high performance computing, or high-end service. In many cases, what we use the whole set of technology, because in some cases, and I have an example in railway stations, where for big railway station, everything is centralized in a command center, and we use high performance compute. But in the meantime, in some stations, there's just a few cameras, and we just need either one edge server or an edge nano to do, for instance, either plate recognition at the entrance of the car park, or facial recognition on 2 or 3 cameras to check who are the people that are entering into the station, for instance. Given what I've described here, we recently have been awarded as the leader of leaders in global edge AI by ISG. So meaning that, and one of the key statement from them is that we are the only company who can provide business consulting on AI, doing system integration on AI, providing software in AI, providing the hardware, and managing the deployment and the overall piece, end-to-end, edge to cloud on AI. With this, I will now hand over to my colleague Timothy from our key partner in AI vision, named NVIDIA. Thank you. Timothy, the floor is yours.
Thank you for the introduction, Mehdi. So what I want to talk today about is the data center in a holistic way. I think that it's already come up from the earlier discussions that AI is a complex solution stack. And if you wish to deploy a full AI solution, you need to think about a lot of things simultaneously. And this is the value that Atos can bring to the customers. This is a value that NVIDIA can bring to customers, is that we have thought about the big picture involved in deploying AI solutions. And that big picture involves looking at the whole of the data center and how you can get maximum value and maximum throughput from a well-designed and coherent data center design. So you might know of NVIDIA. NVIDIA is surely very well known around the world for its graphics processors and the way that we have provided the video gamer with the beautiful graphics experience he can have when playing his video games. But of course, NVIDIA in recent years has been involved in very much more than computer graphics. And that's why, of course, we are partnering with people like Atos who are able to deploy and resell our solutions. And the whole of the picture, this data center picture, comes together with these 4 pieces that I'm showing on the slide here today. And I want to spend a little bit of time looking at some of these in more detail in the later parts of the presentation. So first of all, of course, you need fast hardware. You need accelerated hardware that can take the basic operations that are required and run them at the very best speed. And an efficient and effective data center makes full use of all of the classes of processor that can be deployed within a server. Of course, the traditional CPU, which is very good for single-threaded operations that need a very high throughput on a high speed and low latency on a single thread. The GPU, that is very good for highly parallel operations. And of course, the reason why we've talked so much about AI today is because the algorithms of artificial intelligence map extremely well onto the highly parallel architecture of the GPU. And then the DPU, which is a new member of the NVIDIA portfolio and has come through our Mellanox acquisition, is very much involved with managing the whole of the data center and coordinating all of the data movement and also responsible for security. And I want to spend a little bit of time talking about what the DPU is adding to the data center later on. One day, perhaps we might be adding quantum processors to this picture there, but we're not quite there yet. The second thing to think about is that solving these complex AI problems is a full stack problem. And Atos has presented the similar sort of concept that you need to have the hardware and the computing and the networking, but also the development platforms and the SDKs and the toolkits, so that people can eventually, so that customers and users can finally create their applications and have an efficient way of managing and deploying their applications. Scalability, of course, is vital. AI is a large and complex task, and it's among the largest and most challenging tasks, computational tasks that we have to do today, and therefore being able to scale our applications to cover the full scale of a large data center is important, and that means careful thought about the software design. And then finally, one of the reasons that NVIDIA has been so successful over the years is that we have a single architecture. We have the GPU architecture, and we invest a large amount of money, a huge amount of money in R&D developing this architecture. So once it's been developed, we need, of course, to be able to deploy it in many different places. And we have this one architecture that allows us to deploy solutions across a wide variety of places, of course, PC gaming, as always, enterprise graphics, autonomous driving, AI, HPC simulations, and so on. And it is our good links with our developer community that allows us to develop this ecosystem of many different places where this single architecture can be used. So the world of computing is changing. I started in high performance computing something like 30 years ago, and it was solely on scientific simulation. But the world of scientific computing, the world of HPC, is very different today. We have a lot of, as well as science simulation, we have artificial intelligence, data analytics, visualization, edge computing, as Mehdi spoke about at length in his presentation. And all of these components are elements of the supercomputer of today, of the HPC landscape of today. And because of the very huge amounts of data that we're dealing with, networking is a key aspect of any computing design these days. How can we move around all of this data from the edge to the core, to an appliance, to the I/O, and so on? So how can we move data around very efficiently? Networking is a key aspect of supercomputing these days. And therefore, we need to think in a holistic fashion about the data center as a single unit. A piecemeal approach to assembling a solution is perhaps not so good, and therefore having a coherent architecture, and Atos certainly has many people who are able to design coherent architectures that bring together all of these elements into a harmonious and consistent architecture that can both accelerate the AI and the machine learning, that can move data around quickly, and has the CPUs there doing the parts of the application that the CPU is very efficient at doing. And of course, the whole reason that we're talking today about AI so extensively is that so much of the current and future workload on these large systems is going to be related to AI and machine learning. So a little bit about the DPU and the sorts of places where this can bring value to a solution. And there are three broad areas where it has value, and I don't want to talk about every individual sub-element of this classification. But of course, networking is very important. We need to be able to move data around efficiently, we need to be able to also isolate parts of the system, virtualize them so that there's no interaction from one element to another. And so defining in software our networking infrastructure allows us to have a fine-grained control of the way that data is allowed to be moved around and can be managed. Storage is, of course, very important. I remember talking to one of our customers, and he said, how did he think about sizing his storage solution? Well, he thought of a number and then multiplied by 3, and then he was convinced it was never enough. So there's always we always have more data than we can manage. Storage is a key part of our solutions, and being able to compress and eliminate unwanted data is critical to be able to keep our storage solutions running. And then very important these days is the idea of security. There was a time when we would simply put we would securitize our data center at the edge, one place, so one point of entry into our data center. But now we have a much more severe view of security, in which nothing should be trusted. Every server should look after its own security, and therefore having a device attached to every server, the DPU, that can manage the security of that specific server and look at all the packets that are coming in and out and make sure that everything is working well and securely is a critical part of managing a large data center these days. So as I said earlier on, NVIDIA is a full stack solution. We have the hardware, we provide systems, we provide SDKs, and once you have all of those things, then the full ecosystem can be built up. And it has been a major part of NVIDIA's work for the last more than a decade to grow the ecosystem of accelerated computing. And you can see now we have a billion or more GPUs deployed that can use our platform. We have millions of developers, we have conferences running around the world. We see tens of millions of downloads of our applications, and thousands of applications have been accelerated by NVIDIA's ecosystem. And so, excuse me. So we have here a picture of the NVIDIA data center platform. I want to bring out a few of the things that are shown on here. Right in the bottom left-hand corner, we have the concept of NVIDIA certified and validated solutions. And we have, of course, a partnership with Atos so that when their servers and their edge devices are certified, NVIDIA then can guarantee that the software stack that we deliver will be functioning on those servers. The hardware technology is available both in, there's a broad range of technologies that go into servers, and those servers are ubiquitous in the sense that we have many partners who deliver servers with GPUs in them, and also they're available in the cloud. Once you have deployed the system, you want to be able to manage it well. So on the right-hand side of this diagram, we have some of the elements that go into managing servers. So monitoring of what's going on in your system. And then, of course, if you're an IT professional, you want to be able to deploy these systems effectively. So we work with Red Hat, large suppliers of software like Red Hat, VMware, to ensure a smooth integration of NVIDIA technology into their platforms, and so that they can be easily deployed using, for example, a GPU operator within the Kubernetes ecosystem. And then there are, of course, you can see many other boxes inside this on this diagram, which include the toolkits for machine analytics, machine learning and data analytics, for artificial intelligence, our HPC high-performance computing toolkits if you want to write simulation applications for GPUs, And of course, not forgetting that NVIDIA is a company with a graphics heritage, and therefore we have lots of information, lots of toolkits for rendering and visualization. On the basis of these things, then you can set up the sorts of platforms that people can use, and we have platforms for the various verticals such as smart city, conversational AI, autonomous vehicles, and so on. And so we have here a complete picture of what the NVIDIA data center platform looks like. We've already spoken about the fact that AI is really the application that is driving the world of supercomputing these days. And if you look at the growth of performance over the recent years, you can see that the largest systems in the top 500 list have been focusing on AI as a way of measuring the performance of these of their systems, and that the AI performance is growing faster than the traditional simulation performance. And so one of the reasons for this, of course, is that we do not need the full 64-bit floating point precision in the AI, and by using reduced precision and specific functional units within our processors, we can accelerate AI more rapidly than the performance on traditional numerical computing can be done. Just to show a picture of the sorts of solutions that we can bring up these days, this is a picture of an NVIDIA, one of our NVIDIA's own data centers that our own research scientists use. And you can see here, racks and racks of systems based on this concept of the NVIDIA data center, NVIDIA Accelerated Data Center, and we are pleased to say that Atos has adopted the NVIDIA SuperPod as one of the products that they can deploy to their customers. And we will be in the final section of this presentation talking about some success stories that joint success stories between NVIDIA and Atos, some based on the SuperPod architecture, some based on the Atos Bull-Sequana architecture. So I'd like to finish with a quotation from an analyst who talked about why NVIDIA is successful. And I think this is a very perceptive comment on NVIDIA's strategy, which is that we focus very intensively on our end users. We talk to our end users, they find out what they need, and we make every effort to deliver the products that are going to fit their needs and make sure that they have the full toolkits that they want to be able to access and take advantage of accelerated computing. And so this enables a wide range of use cases that aren't possible without the concept of accelerated computing. And this has been the focus of NVIDIA's strategy for many years and will continue to be so. And so now I hand back to Mehdi, I guess, to lead the final section on NVIDIA's and Atos and NVIDIA's joint propositions.
Thank you, Timothy. So in the previous section of this presentation, we presented Atos offering, NVIDIA offering, and now we're going to present you our joint value proposition. And to present the joint value proposition, best is to speak about some type of project we've run together. First one is a very large retailer who has more than 300 petrol filling stations in the UK, and we deployed both the AI solution and also our hardware powered by the NVIDIA GPUs to serve many use cases. The first use cases were that a lot of people were getting sick because of COVID, and every time someone or two people from the station were sick, they had to close some stations. And it became even dramatic when those stations were nearby hospitals, meaning that some ambulances were not able even to get some petrol from the stations. And that issue was a kind of recurring issue, because in a petrol filling station, people have to get some certification, so we cannot take some temporary workers to do the job in a petrol filling station. We need to have people with fire and safety certification to be able to operate in a station. And we implemented also additional use cases, like counting the number of vehicles, counting the number of people entering into the shop, looking at how much time people were spending on at the pump, meaning calculating the egress time, looking at also some, let's say, some non-standard behavior. For instance, it's forbidden to go to a pump without a vehicle and take some petrol, because the high risk is that that person can put some petrol, let's say, on the ground and just let's say start a fire, for instance. So the pump needs to be blocked at that time. So all these kind of things have been implemented during the COVID period, and deployed also during that COVID period. So basically, the AI capabilities that we deployed in petrol filling station allowed our customer to operate partially unmanned or even fully unmanned during the COVID period. And it has been a huge success. So we deployed it quite easily, because what we've done, we pre-installed all the software, so the OS, the AI piece, including these very specific business rules that have been created for that customer. Everything has been installed in our factory, and we deployed these machines directly in all the single petrol filling station, meaning that the field engineer had just to plug the power, plug the network, and remotely we made the configuration connecting the camera streams to the edge server to run a video analytics real time and send alerts to a remote monitoring system. So it has improved security, it has improved sales, because some stations now are opening also fully unmanned, for instance, even during the night. And we reduced also some staffing costs because of that. The other example that we provided beginning of this year was at New Year's Eve in Dubai downtown, near Burj Khalifa. During New Year's Eve, what's happening is that there's a lot of crowd. And we were in a pandemic, so we needed to count the number of people and also manage the occupancy of that place to make sure that everyone was respecting the social distancing. So we've implemented our computer vision platform with our servers, and also powered by the Nvidia GPUs to provide such service, and with the ability to open, let's say, kind of exit and entrance depending on the number of people who were on site. So that has been a real success, and has been also implemented in a very, very short time frame. Now I will hand over to Cédric, who will be speaking about some use cases.
Yeah, thanks, Mehdi. As I already highlighted in the joint value proposition, we have built with NVIDIA is around Fuse for the HPC world, bringing pre-exascale architecture and platform to be able to design exascale system thanks to the Atos technology and NVIDIA technology to accelerate the computing at a big scale. So Cineca Leonardo system is today one of the biggest reference we have done so far on the Atos side, and really thanks to the GPU capacity we have today, we will be able to build a pre-exascale system. So that's one of the reference we have. And here, in fact, you have the architecture of the Leonardo system, and what I mentioned just before on how we can achieve so much big system and so much performance system is really thanks to the NVIDIA capacity today. So in the overall, you have around 4,000 compute node. But if you look in the detail on what we call the booster module, so the module that will integrate the NVIDIA technology, it represents around two-thirds of the whole number of nodes, but in terms of capacity, the biggest part will come from the GPU acceleration of this booster module. So, for example, Cineca Leonardo is one of the very important system in terms of design, next architecture supercomputer we can bring, and the convergence and the integration of the NVIDIA capacity into HPC system. The other use case and reference we had is around what has been mentioned by Timothy on DGX SuperPod. So we have decided in the Atos side to develop and to partner with NVIDIA on DGX SuperPod, as we really think that is complementing what we have in the portfolio on the AI and HPC system. So we started to work on this kind of architecture a couple of years ago, and in 2020 we delivered a different SuperPod project. Here you have some of the reference we have jointly with NVIDIA, and most of these needs are today on research center that want to bring big AI capacity to research. We also have one customer that is doing a smart city application on DGX. But the objective of the DGX SuperPod is really to have the integration of NVIDIA DGX server into Atos rack, into bringing some infrastructure, cooling capacity, data management capacity we have in Atos, and to integrate the DGX server. So CDAC is a research center, very well-known research center in India, University of Oxford as well. We are working with DGX technology for the AI research in Oxford. And the third one on this slide is VASP Foundation with the link copying system named Berzeliu, which is a 60 DGX SuperPod. And I think Timothy will explain more better what is inside Berzeliu.
Thank you, Cedric. Yes, of course, NVIDIA, being a graphics company, has a very nice and glorious picture of the machine, which we fill the full screen with. This is based on NVIDIA's DGX system. So there are totally 60 DGXs there, so approaching 500 of our latest generation of GPUs. And of course, we must not forget, as I tried to emphasize in my section, the importance of networking, that the Mellanox networking is an essential part of being able to move data around rapidly in these large systems, and particularly for AI. The one thing that we've discovered in our AI journey is that there's a lot of data. You need to move it around quickly, and optimizing the data movement both from server inside the server and from between servers, and of course out to the storage. And you can see our partner DDN's storage system there on the left-hand side of one of the racks there. There's a few boxes of DDN storage. Just to give, I think the final one is going to be an overview of various places, various success stories that we've had in conjunction with Atos around the world. And these cover many countries, many vertical markets. So Petrobras in Brazil is an oil exploitation company in Brazil. We have several in the academic area, and we have had some very good successes in the recent European funding of pre-exascale solutions. So Meluxina in Luxembourg, the Jülich Computing Center in Germany. Cedric already spoke at length about the Chineke solution. And then other regions such as CDAC in India, there's the Indian Supercomputing Center. So many success stories from this Atos NVIDIA collaboration around the world. Thank you.
Thank you. So now I guess we have some time for Q&A.
Yes, thank you very much, Cedric and Mehdi and Timothy. Absolutely brilliant presentations. I mean, I've been making notes. I've filled up almost 5 pages, and it's very fascinating how you divided it amongst the 3 of you, with Cedric looking at the building part of the systems. Mehdi, you're looking at the application and use cases, especially the computer vision part, and then Timothy taking us through the architecture, NVIDIA architecture, and how things are moving, especially the data movement. And I really like that part where you explained, Timothy, about deactivating some of the GPU processors in order to accelerate the application or the data movement. Once again, for all the attendees, any questions for the speakers, please post them in the chat. I have 1 or 2 coming in. So let's look at the security aspect. So Cedric, you're building the boxes, the Atos boxes, if I can put it that simplistically. Obviously, security needs to be inbuilt. And Timothy, you did mention about software-defined security. Between the 2 of you, can you just update? Some of the people want to know how security is being I mean, everything is so innovative in terms of AI and the processing. How is the security being managed? Go ahead, Cedric and Timothy.
That's a very good question. So it's a different combination between technology and risk analysis when you address a security question. So our approach is in Atos is we are one of the global leader in cybersecurity. So we do have many experts in cybersecurity. So we start by making a risk analysis of the system, the platform, the typology of users, the usage of the platform, and then we go through all the risk, or we mitigate this risk on the system, and what kind of technology we're going to bring to secure the system. For example, if I want to build a multi-tenant superpod architecture, there is some way to use and to allocate the DGX between users, to segregate the network with, for example, the Mellanox technology that is able to guarantee the performance, but some segregation between users. So that's a combination of expertise in security and bringing technology to then secure a platform at all the layers, from the bare metal server up to the application layer, and of course the DPU. And I will end to Timothy. The DPU is one of the building blocks that is part of the answer as well.
So I think,
thanks, Cedric. Yeah, go ahead, Timothy. Go ahead, please.
So I think there are 2 technologies that are vital in security. So one is virtualization. And this is a way of being able to, this allows you to isolate the various tenants that are running in your data center. and therefore strong partnerships with leading suppliers of virtualization technology like VMware are a critical part of any security solution. And one of the directions that NVIDIA is going is being able to offload the overhead of running the virtualization onto the DPU, so that the CPUs you've invested in your servers can focus on doing the tasks of running your applications rather than running the security of the system. And then the second aspect, I think, is this so-called zero trust concept, in which a server should have no trust in any information that is being presented to it from other parts of the data center or other parts of the world, and should take responsibility for examining and verifying every packet of data that's coming onto the server. And once again, that's a heavy computational load that you would like to offload to a specialized processor such as the Mellanox technology. So once again, your server can focus on running your application rather than protecting itself from the outside world.
May I add also something, Mehdi speaking? At Atos, we do have a very large cybersecurity business unit. We are one of the global leaders, building hardware like IPsec hardware, building hardware security module to encrypt also the communications. We do have also our own software on identity and access management as well. And we do operate also machine learning powered security operation centers. And one of the, let's say, biggest reference we can speak about now is what happens in the Olympics for the past few years or past decades, where Atos is managing also the overall cybersecurity for the Olympic Games, with billions of events to analyze using machine learning as well, and having a full security operations center running 24/7 to secure the Olympic Games.
Great, absolutely fascinating over there, especially the NVIDIA part, and of course the Atos has the best practices of cybersecurity inbuilt. Now, Cedric, one more thing. When you showed us at the beginning about putting together the systems, there was a lot of emphasis there about energy management, cooling, and the HVAC, and obviously Atos has set its own sustainability targets for 2028. So the question here, which I can see, is huge scalability being built, but on the sustainability, energy, and management side, what are the sort of third-party products where you're taking? Is it an OEM type of relationship, or are they separate contracts which customers have to then look at for all the systems? Go ahead, Cedric.
The answer is we are building our own technology in management and on the cooling side. So we are not OEM of some third-party technology. We are developing our own Atos technology thanks to the R&D capacity Mehdi mentioned at the beginning of the presentation. So all this Atos HPC and cooling capacity and all this management of this system at scale to minimize the consumption and to have the greenest system is a Atos patented technology, in fact, and not OEM or third-party technology.
Great, nice clarification over there. Mehdi, coming to you now, you told us this fascinating concept of computer vision, and it was very nicely illustrated. About 80% of the data is never analyzed because it's either video or images, and therefore is locked in, needs specialized thing. And then, of course, you told us about how the accuracy is improving now, leading to the use cases of AI coming together. But on the edge computing, how does Atos integrate AI at the edge? One of the questions coming in over here. Go ahead, Mehdi.
There are multiple use cases. When it comes to computer vision, we do have a software that probably can serve at least 80 to 90% of the usages. So basically, we discuss with the customer, we look at what they need in terms of use cases, and we have all the building blocks to create the specific use cases that the customer wants to implement. But then if we look at what's happening on IoT or industrial IoT, every single company has his own need, meaning that they have their own processes, they have their set of machines from different brands, and for that usually we bring our experts who will be analyzing what needs to be done to serve customer need. So I have a beautiful example with a very large American entertainment company who is having a lot of IoT systems in the rides they're having. In each ride, there are sensors, and all those sensors are being sent to an edge server, and to determine if there's a potential issue on the machines that are being used by the customers, and we predict when we need to do a preventive maintenance before something happen during the day, and having people blocked with the blocked on a ride, for instance, in the middle of the day. So basically, we bring our business consultants. We build the AI capabilities using any type of AI framework. We play quite a lot with NVIDIA, with all the NVIDIA stack that is being provided, let's say, to accelerate these AI implementation. We deploy them either on the machines or using also some capabilities of NVIDIA. There was the monitoring part. It's not only about monitoring, but it's about fleet management. We use, for instance, NVIDIA Fleet Command to have one image of what needs to be deployed, and deploy it on the edge, manage it on the edge as well.
Interesting, very interesting. In continuation, there's another question coming in. I think you showed the full roadmap of the Bull Sequana servers from Edge Nano to Edge, and then SA20GX, and then above that. Question is that you also showed 4 cameras, 50 cameras, 250. Is it just processing capability, or is it AI scaling capability also, which changes over here? Go ahead, Cedric. Sorry, go ahead, Mehdi.
Yes, thank you. It's clearly about processing capabilities, and then it's also a matter of where that processing capability needs to be located. The small box is a very ruggedized box, meaning that you can do your processing with temperature up to 60 degrees with the first box. So meaning that it could be very close to the sensors or to the cameras in a very, I mean, the goal is to do processing in a harsh environment. The second box, which is the edge servers, is less ruggedized, but could be installed, for instance, in a container, or could be installed in a technical shelter, and do not need any data center capabilities, no cooling, no precise type of, for instance, humidity percentage, etc. And the 2 others are clearly enterprise servers and HPCs, who needs clearly a data center environment, meaning that they are less resistant to dust, and we need to have clearly a well-cooled environment to be able to run them. So compute, and also where the compute has to be located. These are the 2 factors.
Absolutely fascinating over there. And just let me see another question coming in. So Timothy, based on on NVIDIA's capabilities to to manage the full stack of software, whether it is for network, whether it is for data, whether it's security, and a lot of the type of innovations which you're doing around GPU and the quantum also. How do you actually see municipalities, smart governments trying to use NVIDIA and the Atos relationship in smart cities? What are the typical use cases where we're going to see rapid progress over there? Go ahead, please, Timothy.
So I think that this is a consistent message between NVIDIA and Atos, that there is a huge proliferation of edge devices, and that being able to process data intelligently at the edge device is going to be the solution to many of the problems of managing smart cities. Much data does not need to go back to any central processor. So the message that everything is fine is something that you don't need to know about in the control center. So be able to make these decisions at the edge with large, with powerful edge devices, I think is critical to managing the smart city of the future. And there are a couple of aspects to this. One is managing these devices. There's a couple of aspects to managing these edge devices. One is the management of the device itself, deploying the applications, deploying the operating system. You can't send a technician around to thousands of cameras, or you can't send or to hundreds of petrol stations. So you need a way of reliably being able to manage the edge processors. And Mehdi mentioned Fleet Command as NVIDIA's solution for deploying software solutions onto edge devices. And the second aspect, of course, is that the computing demands on the edge devices are growing enormously, and therefore having accelerated edge devices is a key technology, and keeping that architecture consistent between the edge and the data center so that you can smoothly transition applications from the edge to the data center. If, for example, the amount of data becomes too large, or you need a really precise analysis of that data, you can send the data back to the data center, to these large servers, and run the same applications there and return the answers back to the edge system. So powerful edge devices that can be easily managed is the message here.
Very interesting about the movement of applications from the edge back to the core. Mehdi, any comments over there as to how AI is inbuilt in Atos systems to manage this autonomously? Go ahead, please.
Yes, I mean, clearly what is becoming really important is the edge to cloud capability when it comes to having a full loop of AI capabilities. So we can train an AI model, for instance, on the cloud, do the inference at the edge, maybe also collect some data to the edge, send them back to the cloud, so we can improve the AI that will be again redeployed on the edge. And one of the good example here is what we can do, and what is being done by the way in computer vision, where in manufacturing to detect defects in factories. And in many cases, what's happening is that the defects that you will find in KSA, the defect that you will find in China or in a European country won't be the same, even though the factories are, let's say, are a kind of copy-paste factories, meaning they have the same processes, they have the same machines, and those defects could be easily shared across the different factories. So we have a unique catalog of defects, and so we can also test all those defects coming from all the factories, and have a kind of the best product we can get, as we will run all the tests that and we will ensure a good quality of the product at the end. So, and that can be done only with an edge to cloud and a cloud to edge continuum.
So very interesting over there. We heard a lot about Industrial Revolution 4.0, but this is something which we haven't heard much about, especially how Atos is managing on the manufacturing types of things. So absolutely fascinating answers over there, absolutely fascinating presentations. We are running short of time, but before we do that, I'd like to have all three of you give your key takeaways, recommendations, some thoughts for the audience as we close, so that they can keep it in their mind. So starting with you, Cedric, key takeaways, best practices, go ahead, please.
I would say that please keep in mind that whatever the need you have, Atos and NVIDIA can answer to these compute needs. Keep in mind that for the future, the AI compute need will grow. So any, I would say, any new project that is starting need to be evaluate in the sense that it should be scalable for the future. I think it's key for the next years, and I think it's all for me.
It's very interesting over there. Let me just see another question. Let me just check. Okay, somebody is requesting the presentations. We'll obviously make them available. The recording will be made available for all the attendees. So Mehdi, key takeaways and best practices you would like to share with the attendees. Go ahead, please.
Clearly, few years back, to differentiate from one company and another, the process was key. Having very good processes was key. Now, the differentiation comes from the companies who are augmenting their business processes with AI and compute capabilities to run that AI. And this is how company will bring more and more innovation in the future and more better serve their customers. So investing in AI capabilities and in compute capabilities will bring differentiation to your company and will bring also sustainability to the companies, because the leaders of tomorrow are the AI leaders now.
Yes, absolutely fascinating takeaway over there, both from Cedric and yourself, saying that anybody who is going to invest into AI and compute, make sure it's scalable, and that is obviously going to be the sustainability and competitive sustainability of the future, because AI is definitely going to revolutionize everything. Timothy, your key takeaways, your best practices that you'd like to leave with the online attendees. Go ahead, please.
So I think I'd like to remind the attendees of one of the titles of one of my slides, which is the data center is the new unit of computing. So you cannot deploy a solution piecemeal. The solution has to be designed in a coherent way. That means all of the hardware components, and that includes also the software stack that's running on your data center. And it's only by considering everything together when you are conceiving your design that you can deliver a solution that is functional and effective and efficient, easy to use and easy to manage.
Great, thank you, Timothy, over there. So with that, I would like to now formally close the session. So on behalf of Global CIO Forum, Atos and NVIDIA, and all this and the speakers here, Mehdi Kasmi, Dr. Cedric Bourassath, Timothy Lanfair, I thank all the attendees for sitting through this 90+ minutes of absolutely engaging content and discussion, and lots of positive feedback coming for the speakers and their presentations. Somebody is saying that they were very well presented, very very clear content. So we look forward to seeing all the attendees once again. Goodbye and thank you.